Hi all. So up till now we were studying about the convection heat transfer, which is nothing but the energy transfer from the surface to the surrounding fluid, which is either moving or stationary. If it is moving, then it is forced convection. If it is moving fluid, if it is stationary fluid, it is natural convection. If it is moving fluid, then it is forced convection. So we were saying that convection is due to the combined effect of conduction and the bulk fluid motion. Bulk fluid motion has got another name, which is nothing but the advection. So advection is the transport of thermal energy due to the bulk fluid motion. So if we combine them, conduction and advection, so we can see here that convection is derived from and from here. So that's how convection has been derived. In convection heat transfer, our main objective is to find the heat transfer coefficient. If we want to find the heat transfer in the convection, so we can find that using the Newton's law of cooling. This relation is valid irrespective of the mode of convection heat transfer. So our main objective is to find this property, the convection heat transfer. So H is very complex property. H is known as convection heat transfer coefficient. It is a function of various parameters, so that's why I said it is complex property. It depends on the nature of the fluid flow, like it is laminar or turbulent. So nature of fluid flow, H is function of nature of fluid flow, and nature of surface, whether it is smooth or rough, and fluid properties, etc. Many other properties, many other parameters depend on, like orientation of the surface, like it is horizontal, vertical, and all. So this is the convection heat transfer coefficient, and this is heat flux from the wall. This is watt per meter square. This is heat transfer rate of heat transfer per unit surface area of the wall, and H has a unit of watt per meter square Kelvin. Higher the value of H, better is the mode of convection heat transfer coefficient. Like these values are listed in this table, as you can see. So boiling condensation has got the highest values of convection heat transfer coefficients. So in laptops we see heat pipes. Heat pipes work on the principle of boiling and condensation. In boiling, heat transfer from the CPU is transferred to the fluid inside, and that fluid get evaporate, and it moves to the other side, and it will transfer that heat to surrounding, and again that fluid comes back to the CPU location, again take the heat from the CPU and go back to other location where vent is there, and it transfer the heat to surroundings. So that's how heat pipes are used in the laptops to cool, and they employ this phase change convection heat transfer process. Now we will focus on radiation heat transfer. So what is radiation? In undergrad, in school level physics, we have studied about the electromagnetic waves. So in radiation is nothing but the electromagnetic waves. So as thermal engineers, we are interested in the thermal radiations. So what are thermal radiations? Thermal radiation is energy emitted is nothing but the energy emitted by matter which is above absolute zero temperature. So any matter which is above absolute zero temperature, it will emit radiations. That is at a non-zero absolute temperature. While talking about the radiation, always keep remember that unit of temperature we have to use is always Kelvin. Always Kelvin. So mark this point. Always in radiation. So as I said that radiation energies, thermal energy in the radiation field is transported by the electromagnetic waves. So thermal energy of the radiation field is transferred by electromagnetic waves or conversely photons. Since it is transported by the electromagnetic waves, it is transferred by the electromagnetic waves, and we know that electromagnetic waves travels at the speed of light. So, and the speed of light is the highest speed. So that's why we say that radiation is the fastest mode of heat transfer as compared to conduction, convection. So radiation is the fastest mode of heat transfer. In radiation, we have to understand some of the terms which are very much important concerned with radiation. So first one is emissive power. As the name suggests, it is the rate at which energy is emitted by the surface per unit area. Rate at which energy is emitted by the surface per unit area. It is in watt per meter square. And so if this is This is the so if this is the surface, if this is the surface, so whatever the amount of heat it is rejecting owing to its temperature will be the emissive power, and rate at which it is transferring energy is emissive power. So upper limit of the emissive power, which is the maximum emissive power the body can emit, is given by the Stephen-Boltzmann law. So upper limit of emissive power is given by the Stephen-Boltzmann law. Stephen-Boltzmann law, which is given by EB is equal to sigma Ts power 4. T is the surface temperature. Sigma is the Stephen-Boltzmann constant. Stephen-Boltzmann constant, which is nothing but 5.67 into 10 power minus 8 watt per meter square Kelvin power 4. So this is the upper limit, which is the maximum value the body can emit. So this is possible only for ideal surface, which is nothing but black body. Since this expression is valid only for black bodies or ideal bodies, so we have to find the expression for real body. So which is found by correcting this formula by multiplying by some correction factor, which is nothing but the emissivity. So for real surface is nothing but epsilon sigma Ts power 4. Epsilon is emissivity of the surface. This is for real surface, real body of real surface. Emissivity, epsilon is emissivity. Emissivity is strongly dependent on the surface material and finish of the surface. And the next term which is of concern is